Today we're going to be talking about how to use the definition of the Laplace transform to find the Laplace transform of t cosh of 3t. This is also going to be a great example of how to use integration by parts when you have three functions inside your integral. Before we get started, let me say that I would not recommend watching this example if you're just wanting to learn how to use the definition of Laplace transforms. I would recommend watching this video if you're interested in using the definition to find the Laplace transform of a function that ends up having or an integral that ends up having three functions inside of it, or if you're just interested in integration by parts with three functions in the first place. So remember that what we're trying to do here is we've been given the function t cosh 3t, and we've been asked to find the Laplace transform using the definition. So remember that the definition asks us to take the integral from 0 to infinity of e to the negative st times our original function. So we've got our original function, which we'll call f of t, as t cosh 3t, and we have to plug that in here to our integral. Now the problem we have, and the problem a lot of people run into, is once you do that, you have three functions. You have e to the negative st as your first function, you have t as a second function, and now you have cosh 3t as a third function, and you're not quite sure how to take the integral. Well, as it turns out, you're going to use integration by parts, but it'll get a little complicated and a little bit involved. So what we'll do, and keep in mind, we're going to use integration by parts many times in order to get to our final Laplace transform. If you're just using integration by parts in general to find the integral of three functions, basically in a nutshell what you're going to do is group two of the functions together. So for example, we'll call u, for our first step here, we'll call u equal to t, and dv is going to be equal to the other two functions, so e to the negative st times cosh 3t. And what you'll do is kind of group things together like this, and then you'll sort it out later as you do multiple integration by parts steps. So like I said, for our first step, we'll set u equal to t, and then we'll find du to be dt, the derivative. dv we set equal to the other two functions. And now in order to find v, we run into something a little bit difficult because we have to take the integral of e to the negative st cosh 3t in order to find v. So that's going to take us a little bit of time, but I want to show you guys how to do that. So if I want to find the integral, right, and we're looking at the integral here of this dv in order to find v, we're going to find the integral of e to the negative st cosh 3t dt. So in order to do that, we're going to need to use integration by parts again, because now we have two functions, e to the negative st and cosh 3t. So we'll set u equal to cosh 3t, and you should, in these kinds of problems, almost always set u equal to the trigonometric identity here. And then we'll set dv equal to e to the negative st dt. So to find the integral of dv to get v, that's not too bad. Remember that s is a constant, so we'll just bring that negative s out here into the denominator of our coefficient. So negative 1 over s e to the negative st will be v. To find du, we'll just take the derivative of u, and that of course is just hyperbolic sine of 3t, but then we have to multiply the 3 out in front here. So we have 3 times hyperbolic sine of 3t dt. All right, so now that we have that, we can go ahead and plug those in to our integral. So I'm going to try to save some space here, and I'm going to put it up here. So we've got u times v. Remember, the integration by parts formula is u dv is equal to u times v minus the integral of v du. Okay, so we have u times v, so we'll get negative 1 over s e to the negative st times cosh 3t minus the integral of v du. So because we have v equal to negative 1 over s e to the negative st, we'll take this negative sign and combine it with this negative sign, and we'll turn those into a positive. So we've got positive We'll also bring that 1 over s out in front of our integral because it's a constant, s is a constant, so we can pull that out in front. So plus 1 over s times the integral of e to the negative st, that's our v, times du. So we've got 3 hyperbolic sine of 3t. We'll bring the 3 out in front here, so now we've got 3 over s, and then hyperbolic sine of 3t dt. All right, so we're in good shape except that our integral over here needs integration by parts again. So in order to do that, we'll come down here and let's distinguish these two. We will, in fact, let me do this. We'll do it right underneath. So to find this part, we'll set u, again, equal to our trigonometric identity. So hyperbolic sine of 3t. We'll take the derivative to get du, and we'll get 3 cosh 3t. And then dv is going to be equal to the other part of our integral, so e to the negative st dt. And then the integral v will get 1, or negative 1, over s times e to the negative st. Okay, so now that we've got that part, we'll take this whole equation down here, and we'll say that the integral of e to the negative st cosh 3t dt is equal to negative 1 over s e to the negative st cosh of 3t plus 3 over s. And now we're going to take this information here and plug it in for our integral. So I'm going to draw a big bracket, and now we're going to use this right side of our integration by parts formula and plug that in for our integral. So we need u times v, so we've got negative 1 over s e to the negative st times hyperbolic sine of 3t minus the integral of v du. So v times du will have plus 3 over s out in front again. So that'll come out in front, and we'll be left with e to the negative st cosh of 3t dt. And I forgot my little dt right there. Okay, so what's great about this, and let's actually go ahead and let's do some multiplication. So what we'll end up with, let's distribute this 3 over s right here. So we'll have, when we combine these two right here, we'll have negative 3 over s squared. So let's go ahead and write that down, negative 3 over s squared. When we distribute here, right, we'll end up with positive 9 over s squared. So now we've got, oh, we don't need this plus sign anymore. We'll end up with minus 3 over s squared here, and we'll end up with plus 9 over s squared. Okay, so what's great about this now is that if you can see, our original integral was equal to e to the negative st cosh 3t dt. And you can see that our new integral over here, e to the negative st cosh 3t dt, are equal to one another. So we can subtract this whole part here from the right-hand side to bring it over to the left. So what we'll have is the integral of e to the negative st cosh 3t dt minus 9 over s squared times the integral of e to the negative st cosh 3t dt. And that'll be equal to negative 1 over s e to the negative st cosh of 3t minus 3 over s squared e to the negative st hyperbolic sine of 3t. So now on the left-hand side, since these two are equal to one another, we can factor them out. And what we have is 1 minus 9 over s squared. And instead of writing the integral, let me just say the integral, right? Dot, dot, dot. So we have that times the integral equal to the right-hand side. Well, what we can do is in order to solve for the integral, we'll just end up dividing both sides by this 1 minus 9 over s squared to bring it over to the right. So what we'll have, 1 minus 9 over s squared, what we'll have is the integral of e to the negative st cosh 3t dt is equal to, we can take this whole thing and divide by 1 minus 9 over s squared. Well, let's do some work on that. Let's combine the two terms in our denominator. So let's call this, instead of 1, we'll call it s squared over s squared. That'll just give us s squared minus 9 over s squared when we combine those two fractions. So we'll get s squared minus 9 over s squared. Now we can multiply by the inverse, right? So we can bring this up into the numerator by multiplying by the inverse. So we'll get negative 1 over s e to the negative st cosh 3t, and we'll multiply here by s squared over s squared minus 9 minus, and let's give ourselves some space here, minus 3 over s squared e to the negative st hyperbolic sine of 3t times s squared over s squared minus 9. Great, so now we can start canceling a little bit. So you can see here in our first term we've got sine squared in our s squared in our numerator and s in the denominator. So this s will go away here and the squared will go away there. In our second term, we've got s squared in the denominator and s squared in the numerator, so those will both go away. This will just turn into a negative sign here, negative, and now we can really just combine. So let's go ahead and make this negative s over s squared minus 9, right? We'll combine those two fractions, and then we'll have minus, put this whole thing, we'll do 3 over s squared minus 9, and then this part will go away because we combined those fractions and we duplicated our 3 there. All right, so that's pretty much as simple as we're going to get it. We know now that the integral here, right, this integral was basically what we had to do in order to find v up here. So v is now equal to negative s e to the negative st cosh 3t over s squared minus 9. Well, and actually we can combine these two fractions, right? So we'll have minus 3e to the negative st hyperbolic sine of 3t, and this whole thing will be over s squared minus 9. All right, so now we can give ourselves more space here. Give ourselves more space. And now we can go back to our original integration by parts. So now that we have u and du, v and dv, we can perform our original integration by parts, and we'll be much closer to solving our original integral. So again, here we're going to say that the integral from 0 to infinity of e to the negative st t cosh 3t dt is equal to u times v. So we have u and v. Really, we're just going to be multiplying this huge fraction we just found by t. So we'll get negative s, and let's go ahead and put that t in there, e to the negative st cosh 3t minus 3, we'll incorporate the t here as well, e to the negative st hyperbolic sine of 3t all over s squared minus 9. And of course, remember, because with the definition we're evaluating on the range 0 to infinity, we can evaluate this on the range 0 to infinity. but we're only halfway through our integration by parts formula, so we have to subtract and still do the v du here. So minus the integral of v du. V is going to be equal to the huge fraction again that we just found, and du is just dt. So what we'll do is see how we have the two negatives in front of these two terms, a negative here and a negative here, and we have a negative in front of our integral. We'll just go ahead and make that a positive, and then the negatives in our fraction will go away. So we'll have se to the negative st cosh 3t plus 3e to the negative st hyperbolic sine of 3t all over s squared minus 9, and then we've got dt in here. Okay, so now that we have that integral, and this we're going to be evaluating on the range 0 to infinity as well. So we'll do a couple things. First, let's go ahead and evaluate this first fraction on the range 0 to infinity. Remember that we're going to be plugging in for t. S is a constant, it's not a variable, so we'll be leaving s in there, plugging in for t. So essentially, you can plug in infinity for t first, right? So when we plug in, notice that we'll plug in infinity here. We'll get e to the negative infinity. Well, e to the negative infinity is just going to be 0. So that whole first term in the numerator is going to go to 0. Then we'll have minus, again here, when you plug in infinity for t, that e to the negative infinity will go to 0. So you'll have 0 again. And then s squared minus 9. That's what you get when you plug in infinity. And then we'll subtract and plug in our lower limit of integration, which is 0. You can see because we're plugging in 0 here for t, that the first term again will go to 0. When we plug in again for t in our second term, we'll get 0 over s squared minus 9. So you can see really that you've got 0 minus 0, that whole thing is going to cancel out. So this really just goes away. And then we're just left with the integral. So there we have the integral, and the integral we can split into two pieces. So we'll have the integral from 0 to infinity. We're going to split it here at the plus sign. So we'll have s e to the negative st cosh 3t over s squared minus 9 dt, and then we'll say plus, and we'll just separate our integral like this. So we've got 3e to the negative st hyperbolic sine of 3t over s squared minus 9 dt. Okay, now this looks more complicated than it actually is. Remember that s is a constant. So what we can do is bring some things out in front here. First of all, s squared minus 9 is going to be a constant, because if s is a constant, imagine if it's 2, for example. You've got 2 squared is 4, 4 minus 9 is negative 5. That whole thing, that whole denominator turns into a constant. So we can pull that out in front as well as the s in the numerator. So we have s over s squared minus 9 times the integral from 0 to infinity of, now we just have e to the negative st cosh 3t dt. And then here again, in the second integral, we can pull out 3 over s squared minus 9. So 3 over s squared minus 9 times the integral from 0 to infinity of e to the negative st hyperbolic sine of 3t. Okay, so the good news is we already know that the integral, remember, if you'll notice, that this e to the negative st cosh 3t dt is the exact same thing as this, and we already know that the integral is v, right? We already found the integral here, it's v. So we can go ahead and plug that in. We'll get, and let me go ahead and write it over here so I've got more room, s over s squared minus 9 times, we'll go ahead and plug in v here, so negative s e to the negative st cosh of 3t minus 3e to the negative st hyperbolic sine of 3t over s squared minus 9. And we're going to be evaluating that on the range 0 to infinity. Okay, so we'll do that. Then for our other integral, we could do the same thing that we did when we found the integral of dv to get v. It's the exact same thing we did before, except instead of setting u equal to cos 3t, we'll set it equal to hyperbolic sine. So what we would do, I won't go through it so we can save some time, but you would set u equal to hyperbolic sine of 3t. You'd find that du would be equal to 3 cos of 3t, and you'd say that dv dt, you'd say that dv was equal to e to the negative st dt, and find that v is equal to negative 1 over s e to the negative st. And you would plug that in and you'd do integration by parts and you'd find that fraction. What you'd find is that you'd get here, you'd find that the integral was equal to the fraction negative e to the negative st times s times hyperbolic sine of 3t minus 3e to the negative st times cos of 3t all over s squared minus 9 again. And of course we'll be evaluating that on 0 to infinity as well. All right, so now that we've got that, we're done integrating. We won't need to do any more integration, and we'll just be evaluating our definite integrals. So let's give ourselves as much room as we can get. And now this will be fairly quick. So we'll say s over s squared minus 9. Remember that when we evaluate our definite integrals, we're plugging in for t. So let's take our first one here. We'll plug in for infinity first. When we plug in for infinity here for this t, we'll get e to the negative infinity, which is going to go to 0. So that whole first term will be 0. Second one, same thing. We'll plug in here, and we'll get e to the negative infinity, which is going to give us 0 squared minus 9. And then when we plug in 0, we'll subtract, we'll get negative s e to the, e to the 0 is going to give us, well, we'll just write it here. So we'll get negative s times 0, which is just going to be 0. So we'll get e to the 0 times cos of 0 minus 3e to the 0 times hyperbolic sine of 0, all divided by s squared minus 9. And then over here, we've now evaluated our definite integral, so we'll just have to simplify that. For our second fraction, we'll get 3 over s squared minus 9 times, when we plug in infinity for t, we'll get e to the negative infinity for this term, which is going to give us 0. So again, that whole first term is 0. Minus, again, here, 0. So minus 0 over s squared minus 9, minus whatever we get when we plug in 0. So we'll get negative e to the 0 times s times hyperbolic sine of 0 minus 3e to the 0 times cos of 0 all over s squared minus 9. Okay, so s over s squared minus 9. This term's going to go away. E to the 0 is equal to 1. First of all, these two negative signs are going to turn into positive signs. So those will go away. Oh, and this one into a positive sign. So we'll just have 1 here for e to the 0. Cos of 0 is also just 1, so that's going to go away. We'll have s plus e to the 0 is 1. Hyperbolic sine of 0 is 0. So we're going to have 0 for that whole term. We'll be left with s squared minus 9 plus 3 over s squared minus 9. This term's going to go away. Again, hyperbolic sine of 0 is 0. So that whole term will go away. These two will turn into a positive. So we'll be a positive. Cosh of 0 is 1 and e to the 0 is 1. So we're just left with 3 over s squared minus 9. And we can cross that out. We're going to get s over s squared plus s squared minus 9 there. So when we simplify, s squared over s squared minus 9 squared plus 9 over s squared minus 9 squared. Since we have common denominators, we can combine our fractions and we'll get s squared plus 9 over s squared, the quantity s squared minus 9 squared. And that's going to be equal to, we'll call it capital F of s, which is going to denote our function in terms of s. And this is our Laplace transform of the function t cosh of 3t using the definition of the Laplace transform. So that's it. I hope this video helped you guys, and I will see you in the next one.